welcome to lesson 4.5 in geometry. Okay, I'm going to start with the warm-up, which is a little review from 4.4, which our quiz tomorrow is on 4.3 and 4.4. Don't you forget about it. The directions say, state if the triangles can be proved congruent by side-to-side or side-angle-side. Then write a congruency statement. Okay, these ones are a little more challenging. Now in number 1, all they showed me were like 2 congruent sides. So I don't have a third side to use side-to-side, and I don't have an angle, the included angle, to use side-angle-side. But what they do tell me is that these lines are parallel, or those two sides are parallel. So if it helps you to do this, like kind of extend the parallel lines here, this might help you to see it. We have this transversal right here. And if I'm looking at these two angles, because I'm trying to look at this included angle between the two congruent sides, what classification would those angles be? Good. Corresponding angles are congruent, right? These are corresponding angles. So they are actually congruent. This one and this one are corresponding. So I do have a side angle side situation here. Okay. I have side, angle, side. Side, angle, side. SAS. Side, angle, side. My congruency statement is stating that those two triangles are congruent by using side, angle, side. So I'm going to call this triangle. I'm never going to go in the order. So if I start here with T, P, Q, I kind of go down one hash mark, then over to the second hash mark. If I call that T, P, Q, then I have to be consistent with my other triangle and call that SQR. Okay, that'd be my congruency statement. In number 2, all that's marked for me are these two congruent sides, CF and ED, and these two congruent sides, CD and EF. And I see that they share this third side. There's nothing marked about the angle. There's no like right angles marked. There's no parallel lines or anything like that. But what do I know about this side? It's shared, which means it's congruent to itself, right? Technically reflexive property. You didn't have to state all that. So what's my setup here? Side, side, side. Yep, side, side, side. Those two triangles would be congruent. Side, side, side. All right, so my congruency statement for this, I did, and I usually just kind of go down the hash mark. So if I do like F to C to D, I have to be consistent with that F, C, D. Then I would have to do D, E, F. All right, so that's what they're looking for the first two. So you can definitely expect to see side, 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 angle, side, write congruency statements, writing corresponding congruent angles, corresponding congruent sides, that good stuff. That's kind of what we did in 4.4 with congruent triangles, or sorry, 4.3 with congruent triangles. All right, and the way to prove here. So I did give students the hint that in these little boxes here, this is actually a 4-step proof. They just gave you 2 lines to state what's given for you, and that's where we always start. So I know line segment YZ bisects UV and XY. That's given to me. And then what also is given to me is that UZ, line segment UZ, is congruent to line segment VZ. And my reason would be given. Okay, so let's go ahead and mark what's kind of given to us here. We know YZ bisects line segment UV, this one, and it also bisects XW. Okay, what we also know is that line segment UZ, which is this one, is congruent to VZ. Now look what we're trying to prove, because there's kind of a lot going on here. You're like, what the heck, there's so many triangles, right? We're trying to prove triangle UYZ, that'd be this one, is congruent to VYZ. We're trying to prove those little ones are congruent. Okay, that's our goal. Yes, Gwen?
Wouldn't it be UY and congruent to YV?
Yes, that's our second step. Beautiful. UY is congruent to YV, she said. Okay, how'd you know that, Gwen?
Definition of midpoint.
Close. Do we know it's a midpoint? We know it bisects. So definition of a bisector. Exactly. Yep, that would be our next one. Definition of a bisector. Good job. All right, so right now I know two sides are congruent. So I can either prove the third side is congruent, or I'm trying to prove that this included angle is congruent. What do we think? Here's my third side. Is that congruent to itself?
Yeah.
You betcha. Oops, I probably should have marked these with 2 since I already used 1. Sorry. I probably should mark those with 2. This is congruent to itself. I'll use 3. YZ is congruent to itself. Which property, folks? Reflexive. Nice. Reflexive property. All right, now that I have shown all 3 sides are congruent, I can prove those 2 triangles are congruent. That's what I was trying to prove. So let's state that in our last box here. That'd be our last step, step 4. Just going to restate that. Triangle UYZ is congruent to triangle VYZ by what postulate? Side to side. Yep. Good. Okay. Here's the exciting part. Today we're going to add to our repertoire 2 more postulates that we can state triangles congruent. ASA and AAS. What those stand for, ASA is an angle side angle situation. So it's kind of like side angle side where you have 2 congruent sides in the included angle, but it's 2 congruent angles in the included side. Angle side angle. All right, so in this specific example, if you have angle A is congruent to angle D, which is marked for us. And we have side AB congruent to DE, the included side. Angle side angle B congruent to angle E. So if you have this set up, folks, then you can conclude those 2 triangles are congruent. And again, guys, with postulates, we just kind of assume they're true. There is a way to go through and prove these. I did it when I was in college geometry. We don't have to worry about this in this class. You just have to know how to apply this postulate. So then we can conclude those triangles are congruent by angle side angle. Okay, that's one of our new ones for today. Angle side angle. ASA. And I want to try to pronounce the next one. AAS. Angle side. So in this situation, you can see it's not the included side, but it could also be this other side in this order. Angle side. Angle side. That is also enough to prove congruency with triangles. So if we know, let's go in the right order, angle A is congruent to angle D. And the next angle, B, is congruent to E. And then if you know the side, angle, side, BC is congruent to EF. Then you can state that the two triangles are congruent. All right. The sad news is there's only these 4 postulates. There's not any more than this. Sorry, this is the end of the road. I do have like a little slide at the end of your notes where you put all 4 of them together so you can kind of like look and compare them. But these are the 2 we're focused on today. Angle, side, angle, and angle, angle, side. So you have to know at least 2 angles, obviously, to use these ones. And that's new for us. And we're going to do 1 2-column proof, 1 flow proof, and 2 of a new kind of proof. Oh, it's exciting. All right, let's start with the 2-column proof. I am given that L is the midpoint of line segment WE. All right, I'm just going to highlight that kind of as I go here. WE, L is the midpoint. I'm also given WR is parallel to ED. They want me to prove triangle WRL, this triangle right here, is congruent to EDL. All right, so first we got to state what's given to us. L is the midpoint. It's always good to kind of look where you're going to, see what you're trying to prove. So 2 things are given to me. I have to state them both. There's my statement, reason, given. All right, now those of you that have been coming into like RTI for help, I've heard just like, I just don't know like what order to do it in, and it doesn't technically matter. There's like a couple directions I could go from here. And I personally just start with like what's given to me, because obviously that's going to help you show some type of congruency. So right away I'm given L is the midpoint of WE. So I ask myself, okay, what does that mean? If this is the midpoint, it splits that segment in what? In half, right? So that means this is congruent to that. That's personally where I would start. That line segment WL, or that side of that triangle, is congruent to LE. Definition of a midpoint. Sometimes the textbook, guys, says midpoint theorem. That's the same thing as definition of a midpoint. You can use either midpoint theorem or definition of midpoint. It's kind of the same thing. Okay, so all I really know from that first statement is 1 congruent side. Now, obviously, this set showing me that they're parallel is going to help me show some other angle congruencies, right? So again, if it helps you to kind of extend these lines a little bit, these parallel lines, and then you can see that blue side, the transversal, I'm looking for some angles inside the triangle that could be congruent. Anybody see a pair? Ben? W and E would be congruent. Good. Why? Good job. Angle W is congruent to angle E because they're alternate interior angles. Good. So that's what was given to me. So right now I know I have an angle and a side. So I can either show another side or possibly another angle now that I know angle, side, angle, and angle, angle, side exists. Tyson, idea?
Angle L is vertical with itself.
Yeah, we have a vertical angle here, right? And actually, when I was doing this proof last hour, somebody said that right away. And that was our step 2, and that's fine. Okay, it doesn't matter really what order you do this in, or you could have done 3 first and then 2. So we can't call it angle L, though, because there's lots of angles going on there. We just got to be a little bit more specific. So let's call it WLR. is congruent. Okay, so if I went up that, I'd have to do ELD, vertical angles. Vertical angle theorem. So usually, folks, once you get 3 parts that are congruent, you are going to have one of those setups. Side, 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 angle, or angle, angle, side. What do I have here? Angle, side, angle, right? Angle, side, angle, in that order. So that's enough to state that those triangles are congruent. And you just want to rewrite that statement. Angle, side, angle postulate. If it helps you too, I saw someone do this last hour, like where they kind of like draw a line down their 2-column proofs. You can do that. If it helps you to keep like your statements on one side or the reasons. I like that warm-up problem because it gave you like a little box like that. So if you want to even do that too, if that helps you organize yourself, that's fine. Okay, there's a 2-column proof. That's the only 2-column proof we're going to do today. Let's try a flow proof. Do you guys like these ones better? You love them all, you can't decide?
Yeah.
Same. Okay, here's what's given to us this time. Angle ADB, that's this little guy, is congruent to angle ACE. Okay, I'm going to mark that. Those are congruent. Line segment EC is congruent to line segment BD. Those are congruent. They want me to prove, I'm going to highlight this. They want me to prove angle AEC, that angle right there, is congruent to ABD. All right, so you can kind of see like the 2 triangles that are forming with my yellow and blue highlighter, right? I'm given a lot of information here. I'm given already a pair of congruent angles and a pair of congruent sides. So with flow proofs, you still have to state what's given to you. So I'm going to kind of go this way. You organize your thinking in a bubble and you put your reasons right underneath given. Given. Okay. So looking at like my blue and yellow triangles there. I don't have any parallel lines. I don't have any like bisectors or midpoints. But what angle is in both triangles? Anyone see it? Ooh, what? A. A is in both triangles, right? This guy right here. That's in both triangles. So we can say angle A is congruent to itself. We do that with sides, with the reflexive property. All right, so I have my 3 pieces. I have 2 angles and I have a side, so now I just have to decide which postulate this is. So I look here, and it's not the included side, but if I'm looking at the this triangle right here, it's angle, angle, side, right? It's not angle, side, angle. See the difference? It's angle, angle, side. And same thing with this triangle. We have angle, angle, side. All right, so we can prove the triangles are congruent now. I'm going to call it AEC is congruent to ABD. Now put this on a circle because this actually isn't my goal, but our statement is angle, angle, side. And all of these little statements helped us prove those triangles are congruent. So you want to draw your arrows to that. That's what a flow proof is. So now, can I prove that this yellow angle and this blue angle are congruent. Yes, I can, because now that the triangles are congruent, everything in the triangles are congruent. So now I can actually prove what I was trying to. I'm just copying down that statement. I like to put a box around this one to know that I'm done. Anyone remember our reasoning? That says everything is congruent. CP, CTC. Corresponding parts of congruent triangles are congruent. So those are corresponding angles. We know the triangles are congruent, so those are also congruent. CP, CTC. That wasn't too bad. All right, our new type of proof is called a paragraph proof. And it's literally the exact same thing as a 2-column. You just have to like write it out in sentences, but I'm gonna let you use math symbols. Okay, so like instead of like writing out the word line segment WL is congruent to, I'll let you like shorthand it with math symbols because it's good to know what those mean too, okay? And you can do that in your homework too. So it's pretty much everything we've been doing, just putting it into like complete sentences, really. It's not bad. So like taking a statement like this, you could say that by vertical angle theorem. Complete sentence. All right, and it's good to practice some more proofs. Here's what's given to us. AE is perpendicular to DE. Now they marked this 90-degree angle for us, but technically they probably shouldn't have done that. That's technically not given to me, but we know those two lines are perpendicular. And that line EA is also perpendicular to AB. What else is given to me is that C is the midpoint of AE. Okay, just like before, we always have to start with stating what's given to us. So in a paragraph proof, if I'm writing this in a complete sentence, I'm just going to say we are given that, and you can just restate that. And again, you don't have to like write out the word perpendicular. You can use shorthand, math symbols. That's what we're given. Now, as I mentioned, they technically shouldn't have drawn in these right angles for us, because that is something we do have to state. Since, and we can do both of them kind of at once, since AE is perpendicular to DE and EA is perpendicular to AB, I know that the measure of angle A is going to be 90 degrees, and the measure of angle E is also going to be 90 degrees. We do need to state that. I know it was marked in the triangle for us, but technically that wasn't part of the given statement. So since they're both 90 degrees, what's true about their relationship? Yeah, say it louder, Gwen. They're congruent, right? So let's say that. So angle A is congruent to angle E. All right, so you have one pair of congruent angles. Next, let's use what else is given to us. That C is the midpoint of AE. So that means it's right in the middle of this line segment. So we have a couple congruent sides. So you can say AC is congruent to CE by the definition of a midpoint. Now you could have said that in like the converse. Like you could say, by the definition of a midpoint, AC is congruent to CE. Okay, that part doesn't matter. However you want to put it in a sentence, but it has to be a complete sentence. Okay, so I'm close here. I have a pair of congruent angles and a pair of congruent sides. What else is congruent? Anybody see it? Alex?
Would it be DC and CD?
These line segments? C is not the midpoint of DB. It could be, but that's not given to us. Good guess. That's not given to us that C is also the midpoint of DB. Tyson, idea?
Angle D and angle B.
Why?
Alternate interior.
Do we have any parallel lines here?
No.
Bummer. No parallel lines, so I can't use any alternate interior angles or anything like that. Any other guesses? I love these. You guys are right on the right track. This is stuff you got to think through and like ask yourself in your head. Dakota, you feel like you have a guess?
Line DE and line DB.
Why?
I don't know.
No, but good guess. These lines, we don't know those are congruent. Do it. Keep looking. Jessa.
Wouldn't AD and DB parallel since AC and AC are perpendicular?
Good guess, but no. We don't know that. It could be like this, right? I could have a perpendicular line here. If that same line is perpendicular, maybe something like that. They might not be the same. Here's my hint. Think angles. Oh! Who said that? Where are the vertical angles? Yep. That one right there. Vertical angles, right? You're going to say that, weren't you?
Yep.
So, okay, you're right. We can't call them angle C, though. We got to say, I'll go ECD. ECD is congruent to ACB by vertical angle theorem. See how easy it is to just put it in complete sentences? All right, now that we've shown 3 congruent parts, what setup do I have here? Angle, side, angle. Is that one of our postulates?
Yes.
Yes, that's one of our new ones. So we could say the triangles are congruent. So triangle CED is congruent to triangle CAB by angle, side, angle. That's one of our new ones. Now, folks, unfortunately, that's not what they asked me to prove. They asked me to prove that CD is congruent to CB, which now that the triangles are congruent, we know all corresponding parts of congruent triangles are congruent. So therefore, those are congruent by the postulate I just said, CP, CTC. There's a paragraph proof. Super fun, right? Okay, we're gonna do one more. This one's shorter though. Don't worry. We're gonna do one more, and then we'll kind of summarize all of our fun postulates we've learned. One more paragraph proof for practice, since this one's new. You guys are doing well. Hang in there. All right, take a look at this one. Here's what's given to us. Angle F is congruent to angle J. Line FH or side FH of that triangle is parallel to line segment GH or that side. All right, so just like before, we are given, that's where we start. We are given that, I'm going to restate that. Angle F is congruent to angle J, and FH is parallel to GJ. So the only thing I know right now is one pair of congruent angles. One pair of corresponding congruent angles. All right, what else is going to be congruent? You can give me a side or you can give me an angle. What do you think? Matthew?
G and H.
GH, side GH is congruent to itself, right? What property, Matthew?
Fluxed.
Yep. Okay, there's complete sentence. GH is congruent to GH by the reflexive property. Okay, so right now I have a side and a pair of angles. I'm going to extend my parallel sides here for you guys. So maybe you can see the next one. Ben, what do you think?
Oh, shoot. Well,
That-
I had something.
Did I confuse you?
No, I'm out of time.
That's okay. Gwen, did you have one?
Angle G and angle H.
Oh,
Yep, this one and this one.
Yeah.
Yes, good. We have a pair of, what are these? Good. Alternate interior angles. Okay, so how we got to write these? So we can't call them G or H because technically there's like two coming off of point H. So let's call it angle FHG is congruent to angle GJH by the alternate interior angle theorem. Again, you can shorthand all that if you want. This is math class. All right, now I have three corresponding congruent parts. I have two angles and a side. So what postulate is this one? What'd you say? I'm actually curious what you said.
AAS.
How did you say it though?
Us.
Don't call it that. angle, side. That was hilarious. Okay. You're right though. Oh, that was funny. Okay, triangle. GHJ is congruent. Sounds like you're swearing in like British accent. It's HGF by, let's just call this one, sorry, no fun short, angle side. Okay, is that what I was trying to prove, guys? Was I trying to prove the triangles are congruent? No. I was trying to prove that FH is congruent to JG, which now I can, by what? Yeah. CT. CTC. No, not necessarily. We just know they're parallel, not that they're congruent. Yep, good question. Oh, thanks for the good laugh.
I actually didn't that wasn't what I thought.
Last hour I was like, angle, side angle. I was like, ASA. And I was like, nah, I probably shouldn't say that. ASA. ASA works better. Oh, that's funny. All right, so here's our four. Here's our four postulates all kind of in one that we've now done. So this one is our set aside. Set aside. This one is side, the included angle. This one is angle, side angle. This one's angle, side. All right. While I pass out the worksheet, I want you guys to look at these. I didn't number them, sorry. These 6 pairs of triangles. Determine which postulate can be used to prove the triangles are congruent. So is it a side, side, angle? If it's not possible, if it's not one of those 4 options, write not possible. Okay? So you guys do that quick. I'm going to pass out the homework while you do that. We have 6 different problems here. Yeah, we could say that 3 angles are, but that's not enough to show that 3 triangles are, or both triangles are. Does that make sense? I like your thinking though. Did you finish those things? Okay.
Is there not a review for
Yeah. I'll pass that on. Thank you. All right, what do we think for this first one over here? Side angle side. Side angle sides included angle. This one. Angle side angle. Angle side angle. What about this one? Not possible is correct. Now, actually, Ben said a really great thing. He said, well, wouldn't we know that these are also congruent because they have to total 180? I'm like, yes. But if we know all 3 angles are congruent, is that enough to show both triangles are congruent? No. Think of like an equilateral triangle where they're all 60 degrees. Could I have a triangle like that big and also like this big that are all 60 degrees equilateral, but those wouldn't be congruent triangles, right? So this one was not possible. Good. This one? Side. Crowd favorite. This one. Angle side. Angle side. This one? Not possible. They're showing you like these are congruent, but nothing between the other two. Good job, guys. Wasn't that fun? All right. I still want to pass out one other thing, but I'm going to stop the video recording quick.